Hello children. So far we have completed with transverse waves, longitudinal waves, isn't it? So I hope you children have got an idea with what is longitudinal wave and transverse wave. Let's have a brief that. So longitudinal wave means it is that wave in which particles vibrate where to and fro. Okay. Whereas in transverse wave, it is a wave in which the particles vibrates up and down. For that we call it as transverse and longitudinal waves. That is easy and clear with that. And moving on to the characteristics of wave. So in characteristics of wave, we have very simple things that I have written here, that is oscillation, then velocity, then amplitude, then frequency, time period and wavelength. These are the things that I have written under characteristics of wave. So in order to that, let's try to understand what is oscillation. So oscillation means it is complete movement of a particle about its mean position. Okay, it is the complete movement of a particle. Okay, let's take one as some particle. So about its complete part. Okay, complete movement of a particle about its mean position. So let's try to understand. Either it may be either to or fro complete. Okay, either it may be to or fro or complete with up or down. That way we can call it as oscillation, rest position to complete. Okay, some wave will be there in order either with to or fro or up and down. So that we call it as oscillation. It is the complete movement of a particle about its mean position is called as oscillation. Okay, then moving on to velocity of wave. What does velocity of wave mean? So velocity of wave mean the speed with which sound travels. Okay, so velocity wave andre the speed with which sound travels. Okay, sound travels along with that. So that we call it as velocity of wave. At how much speed, okay, sound travels. To calculate that, we take velocity of wave. To calculate the speed of sound, how it travels. So velocity of wave we taken, and it is measured through meter per second. Now we yaudರಲ್ಲಿ measure ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we measure through meter per second. And then moving on to the next, that is we have amplitude. So amplitude, you children might have already heard about amplitude. So in this chapter, amplitude means it is the maximum displacement. Okay, it is the maximum displacement. Try to understand, it is the maximum displacement of a particle from its mean position in either direction. Okay, what happens here? Let's try to understand. Okay, let me write it like this. This is one complete wave, isn't it? So up and down, let's take it as like this. So maximum displacement, either it may be upwards to the maximum or to the downwards to the maximum of particle from its mean position. So from here to here, we call it as mean position. And if the next wave continues, that will be the second wave. So mean position are these things. Okay, in either direction, either from left to right or right to left, or even it may be to or fro. Okay, so that will be recorded. So that we call it as amplitude. And then we have frequency. Wow, frequency is very good, and it is important that everyone has to recognize with frequency. So frequency means it is the number of sound waves. Okay, it is the number of sound waves produced from per second. Okay, so frequency means it is the number of sound waves produced per second. 1 second ಗೆ ಎಷ್ಟು sound produce ಆಗ್ತಾ ಇದೆ ಅಂತ. So say for example, I beat here. Okay, so what is the number of sound waves? How many waves produces in second? And that is calculated with hertz. Okay, Hertz, hertz we call it as, and that is measured, frequency is measured from hertz. At 1 second, how much wave is produced? We have to measure through hertz. Okay, that we call it as frequency. And then we have time period. Okay, then we have time period. So time period means time taken to complete one oscillation. Okay, it is the time taken to complete one oscillation. So that one we call it as time period, and that is measured from seconds. Seconds in the measure martivi. Particles complete oscillation, time per time period and frequency both has same relation. Okay, so in this we have both have same relation almost. Time frequency is 1 by frequency. You can write it like this, or it is the reciprocal of frequency, so that you can write it as frequency by time period. So it is the reciprocal, either this or like that. So time period is the time taken to complete one oscillation. Illen oscillation anta kaltidivala, so oscillation na complete madake time period anta ನಾವು ತಗೋತೀವಿ. And then next we have is wavelength. So what does wavelength mean? So wavelength means the distance between two consecutive crest or trough. Okay, so let me try to understand. Okay, this is one complete wave, and then this is second complete wave. Okay, so from here to here, this is crest, we know, isn't it? This is crest, and this is downwards. What we have is trough. Okay, so crest and trough. We denote wavelength through lambda. So wavelength na yaudrinda denote ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ it is this symbol. Okay, put one slant and put like this. So this is lambda, LAMDA. So frequency wavelength is measured through lambda. Got it, children? The distance between two consecutive crest or trough, and we measure through centimeter, and the symbol we use is lambda. This is the symbol lambda. Everybody has to remember this symbol. This symbol barda, it means that it is lambda. Okay, so then moving on to this, we know velocity is equals to meter per second, and then amplitude is equals to, it is denoted with A, and we measure by centimeter, cm. Okay, and then this symbol, write like V and put a round with elaborated structure. Okay, that we call it as mu. That is equals to mu, where frequency measured with hertz. And then time period, as usual, we measure with second, and then lambda with centimeter. Okay, this is about the frequency. So let us try to understand with relationship. So relationship between time period, frequency and velocity of wave. So it is that we are gonna learn. Thank you.